All right. So today we're going to continue with our work on limits, but now we're going to approach them with a different technique if some of the other options that we've talked about don't work. And so we're back in section 1.2. I know we're kind of bouncing around with our text, but this is kind of, I think, a better order for things. So we're going to talk about finding limits using a table of values. Okay. And so the objective here is to obviously find limits using tables, and then there's also a second one that we'll talk about, which is some special. There's a couple of special limits that we're going to get to that we want you to just know. Oh yeah, this is the answer, and we're going to also investigate that using limits with tables. So let's just get right into it. So let's say we want to find the limit as x approaches 2 of the function x minus 2 over x squared minus 4. All right, so now we've talked about our approach. So far our approach is, can I plug 2 in? And if you check it, you're going to get a 0 down there, so you can't. Next is there any factoring and canceling I can do? And in this case, there is. Okay, but we're going to assume, you know what, maybe we forgot how to do that, or we're just interested in looking at a different perspective besides the graph. So we've talked about plugging in, factoring and canceling, looking at a graph, and then this is another option now. Our fourth option is going to be to use a table of values. So now for this one, what you're going to do on your calculator, okay, is you're going to go ahead and put the function into y1. Okay, so you're going to have x minus 2 divided by x squared minus 4. Okay, and there's the graph for it. All right, and we want to know what's going on at x equals 2. So one way to do that is to go to your table settings. Okay, and what we want to do is try to build a table of values, centered around 2. Okay, because we're interested at x equals 2. We want to center it around 2, but then we want to create a table that gets us really close to 2. So not the usual like 0, 1, 2, 3, 4. We want to get really close to 2. So maybe even something like, let's go 1.9, 1.99. Maybe let's do 2.01, 2.1, just to get an idea. All right, and so what we can do now is change the settings on your table. Change this from independent auto to ask. And so now what that's going to do is when you go to table, you'll have a blank table, a clean slate, and it's asking you, okay, what values do you want to know about? And so now you can just type in, I want to know about 1.9, 1.99. And you know what? Let's sneak in 1.999 in here as well. And then maybe 2.001, 2.01, and 2.1. So 2, but then 2.001, 2.1. Oops, let me change that. 2.01, 2.1. Okay. So here's our table. Okay. And so just looking at this, okay, obviously we already know there's going to be an issue at 2, right? You can't just plug in 2 because you can't divide by 0. Therefore, calculator says there's an error. But now, if the limit exists, remember that from the right, so that's from down here, and from the left, that would be from these numbers, right? That these two should be converging to the same value. And it looks, just by looking at this table, like it does meet at the same value. Okay? Now, if you want to get a really, really good approximation, let's go ahead and add in another value here. Let's change this to 2.000001, getting really, really close. And let's change this one to 1.9999. Okay, so look, our calculator now says 0.25, but really this is cut off. If you highlight it, you'll actually see what it's saying. Okay, but now interestingly enough, okay, this is the limit value. Okay, so it looks like this is approaching 0.25, okay, which is 1/4. And so that would be kind of how to use your calculator to get an idea for what the limit's going to be. Okay, let's take a look at another example. Let's say we want to look at the limit as x approach. And you know what? Let me go back and just fill this in so that you guys have it. So for 1.9 we had 2.5641. For 1.99 it was 0.25063. Then we had 0.25006. This is error. 2.001 was 0.24994. 2.01, 0.24938, and this was 0.2439. Okay, so here was our table of values. Okay, better to have it right here, but this was the issue, and we said, well, that looks like it's approximating 0.25, right? So that's how we can use the calculator to figure out what that limit's going to be. All right, example 2. Let's say we want to find the limit as x approaches 5 for the function 2 over x minus 5. All right, so what I would recommend you do is pause the video, see if you can set up a good table to take a look at what's going on, and see if you can figure out the answer before I go over it. So go ahead and do that. All right, so let's go through what it should look like. So I'm going to change this function to match 2 divided by the quantity x minus 5. Go to my table, and I don't like any of those. So I'm just going to reprogram it to approximate 5, right? So maybe what I'm going to do, center at 5, go a little bit past it, like really, really, really close, 5.001, maybe 5.01, and then 5.1. Here we can do 4.999, 4.99, 4.9. And so those are the values I'm going to type in. 4.9, 4.99, and so on. Oops. Okay, so what does this mean? Okay, so it means that as we approach from the left, right, that we are at -20, then -200, and we keep going further and further down. Now, as we approach from the right, we start at 20, then we get up to 200, up to 2,000. Right here is the issue, okay? So one value is approaching -2,000. The other is approaching 2,000. So this actually is indicative of the left-hand limits. And you can write that down if you want. But the left-hand limit looks like it's going higher or lower and lower, maybe to -infinity. The right-hand side is approaching positive infinity. And since these are going in opposite directions, we're going to say that the limit does not exist. Okay? And if you look at the graph, that's going to confirm what we just talked about, right? As we approach, so here's 5. As we approach from the right, we're going higher and higher up to positive infinity. If we approach 5 from the left, we are going further and further down. We're going opposite directions, so the left side and the right side limits are going opposite ways. That's why the limit does not exist. Okay, so now that's kind of how you can use tables to approximate, to get an idea of what's going on with the limits. Now we're going to go ahead and look at a couple of special trig limits. And the table is going to be probably the best way for us to get acclimated with these. But here's the first one. The limit as x approaches 0 of sine of x over x. Okay? And again, going through what we've talked about, you'd probably try plugging in 0. Okay, sine of 0, 0, good to go. But you can't divide by 0, so that's a problem. And this is not a problem where we can factor and cancel and then try replugging in, right? And so we can either look at a graph or look at a table. So let's set up a table here first. Again, we're going to center around 0, and then we're going to approach it from the left, but get really close to it, right? So maybe something like negative 0.999, negative 0.99, negative 0.9. And here we can do positive 0.001, 0.01, 0.1. All right, so that's kind of how I would set up the table. So let's take a look at what's going on. Now notice there's, let's go ahead and change this to radians. Okay, always in radians. And let's type it in, sine of x. That's the numerator, we're dividing, whoops, by x. Table. All right, let's change these values to negative 0.9, negative 0.99, negative 0.999, you know what? That's not what I wanted to do here. We want to be close to 0. This is getting close to negative 1 over here. Let's change these to the exact opposite of these, negative 0.01. That's my bad. Negative 0.01 and negative 0.1. Let's change that around. Come on. Okay, so here's our table setup, and you can kind of see, now it looks better, sorry about that little goof. So as we get close to 0 from the left-hand side on the number line, we are getting really close to 1. I know it says 1 here, but again, if you highlight it, it's going to be really close to it. And this would be 1 if it existed. And then same thing from the other side. So it looks like both ways we are approaching the same value. In other words, the left side and the right side limits are going to be the same. And so here we're going to say that the limit for this equals 1. Okay, now if we look at the graph, let's change our window when we graph this maybe to something normal like negative pi over 2 to pi over 2. Let's go negative 2 to 2 for the y direction. All right. So here's the sine of x over x graph. Okay, and even just by looking at the graph, right, you can see here that we're approaching 1. Certainly if you try tracing, we're getting close to that value. The other way that you can do it, right, approach from the right on the calculator, you can see it's getting close to 1 from both sides. There's a hole there, right? There's no value there, but it would be 1 since it's approaching 1 from both directions. Okay? So memorize this. This is going to be an important one. Let's go ahead and try the next one. the limit as x approaches 0 of 1 minus the cosine of x over x. Okay. Our table that we have up here, we can use the same exact table, right, because we're approximating the limit for 0. So let's just change the function now. Here we have 1 minus the cosine of x divided by x. Let's look at the table. Table's already set up. Okay, and let's explore what's going on here. So as we get closer to 0, here we're about negative 0.05, the negative 0.005, and this is scientific notation. We're just throwing in more zeros, right? This is negative 0.0000, well, 4 zeros and then followed by 4999. On this side, it's the same thing, approaching from the positive direction. Here we're at 4, let's say 5e minus 4. That's really the same as 5 times 10 to the minus 4. So again, move the decimal over 5 times, you get 0.00005. Okay, so either way, we are approaching 0 from both directions. Okay, and again, that's just by looking at the table. If I look at the graph, you can see right there that even though there's no value at 0, okay, that from the left and from the right, we are approaching 0. Okay? All right. Now, so here are a few examples for you guys to try on your own using tables. I want you to go ahead and try these for the rest of the notes, and then I will post the solutions onto Schoology so that you guys can check these, okay? So let's try these 4 questions. The limit as x approaches 3 of x over x squared minus 3x. Let's do the limit as x approaches 2 of x minus 2 over x squared minus 4. Let's do the limit as x approaches negative 1 for the absolute value of x plus 1 over x plus 1. And the last one we'll do, let's do the limit as x approaches 0 for sine of 1 over x. Okay, so try these 4 questions using tables. That's what we're trying to get really comfortable with. So go ahead, use a table of values, try figuring those out. I will post in the folder a document that says limits by tables, last 4 problems, solutions, or something like that. All right, so that's it for the notes. Try these 4 out, check your answers, and then we can go over these if there are questions. All right, have a good day.